Graphing square root functions. Y equals the square root of x. It says it's half of a parabola laid on its side. Now, let me draw the rest of the parabola for you. I'm going to make it a dotted line just so you get perspective. Okay? You see the other half? When you rotate, does it look normal? Now let's talk about why you can't have that bottom half. Give or take, this is the point 4, -2, right? Let's put that into the function. X equals y, right there. So we have y equals the square root of x. Let's put that in and see why it doesn't work. What's the square root of 4? 2. What is it not? -2. So the only part of the parabola that you can have is the top part. We can have 4 +2, but you can't have 4 -2. Now let me teach you something about parabolas very simply. Go over 1 here and go up 1 and put a dot. So that's the point 1, 1. Now go over 4 and go up 2. That's the point 4, 2. How far would you have to go over to get to the next one up? 1, 1, 4, 2, what?
8, 3.
Is 3 squared 8? What's 3 squared? 9. So go over 9 and up 3. And that's your frame. And this is obviously 0, 0. So that's your framework for your parabola. When you turn it on your side, you have a square root function. And so what I did here is I just made a very simple table. And that's how I plotted those points. The square root of 2 is 1.4. The square root of 3 is 1.7. And so I plotted those points on here, and I got this graph. Now I should put an arrow here, because there's more off the graph than on the graph. But that is the basic graph of a square root function. It's just going to go up 1 over 1, up 2 over 4, up 3 over 9. Remember that basic function. 1, 1, 2, 4, 3, 9. And that will give you the shape of the curve. All right? So what I want to talk about today is how we move a graph around. You guys all know cut and paste, right? When you take a figure or a picture on the computer in a Word document, and you can cut it, and you can slide it right, slide it left. That's all formulaic, that the computer has a program built into it that allows you to do that and move things like that, and it's all in a grid coordinate. Okay, and what we're doing here today is talking about the basics behind some of that material. So, watch what happens. When we have a -3 at the back, all right, which way do you think the graph is going to move? Yeah, it's going to move down. So what I'm going to do is I'm going to draw the original one. 0, 0, 1, 1, 4, 2, and 3, 9. And everyone put that on there.
Is it always going to be like that?
Yeah, it is. But draw it with a dotted line. Okay, once again, that was 0, 0, 1, 1, 4, 2, and 9, 3. Put those 4 points on there. Now notice, why did I make a dotted line? Is it really there? No, it's just a reference. Now Josh made a prediction that it is down 3, and he's correct. So take each of these points and go down 3. 1, 2, 3. Take this point, down 3. 1, 2, 3. Take this point, 1, 2, 3. And take our last point, 1, 2, 3.
Wait, how did you know to get this point?
Because right here, this -3 means the whole parabola goes down 3.
No, like the first point to start out.
Oh, because it's the square root function. And the standard square root function, okay, y equals the square root of x, 0, 0. What's the square root of 1? What's the square root of 4? And what's the square root of 9? So our points are x, y, just like that. And so that's how I graphed 9, 3, 4, 2, 1, 1, and 0, 0. Now, the top one was dotted. How am I going to draw the bottom one?
Solid.
Solid, because it is actually the graph. Put an arrow at the end.
Is it always going to be facing up though?
No. But first I'm going to show you some ways to slide it. That was a slide down by minusing 3. Look at number 2. It has a plus 2 at the end. Which way is it going to slide? Up. So let's do our standard graph with our dots. 0, 0, 1, 1. What's the next one? 4, 2. And the next one? 9, 3. Do your dotted line again. That's called the parent graph. Why do you think the parent graph is called that compared to the real graph? Within reason, do you look like your father or your mother? Okay? You are made in the image of God. You are made also in the image of your parents. Okay? So the graph looks like its parent. So, as Ryan said, this is shifted up 2. So go up 2, go up 2, go up 2, and go up 2, and draw your graph. It should have the exact same shape. Thank you. Okay. All right. Josh, you had a question. Oh. Okay. So we shifted up by adding. We shifted down by subtracting. What haven't we done? Okay, flipper. By the way, horizontal shifts are also called translations. All right. On our backside, I gave you some key up the top. I said if it's x plus a number, it shifts to the which direction?
Left.
To the left. And if it's x minus, it shifts to the right. And let me try to help you understand why that's true. What if x equals negative 4? Let's plug it in. What is negative 4 plus 4? What's the square root of 0? So if x equals negative 4, y equals 0. So I'm going to put our normal one on here. 0, 0, 1, 1, 4, 2, 9, 3. I want you to do that on your homework. I want you to see that parent function each time. Make sure, though, when you write your parent function, Drew, dotted lines. It's a reference. It's not the graph. If you make that solid, you just made it part of the answer. Don't do that. Okay? Now, we're going to shift our points 4 to the left. 1, 2, 3, 4. Where are we right now? What's that point? Negative 4, 0, isn't it? And that's why it works. 4 to the left. 1, 2, 3, 4 to the left. 1, 2, 3, 4 to the left. And do your sketch. So far, so good? Which way does this one shift? All right, let's do our parent function. Shifts 4 to the 1, 1, 4, 2, 9, 3. So once again, if it's a minus 3, it shifts 3 to the right. So 1, 2, 3, 1, 2, 3, 1, 2, 3, and off the graph. Yes, Gesundheit. So far, so good. Who feels like they get the shifts? Most of us? All right, let's slide back to page 46. All right. If you think you know which way the shift is, raise your hand. I'm going to write an equation. You tell me which way the shift is. Here we go. Number 1. You can only answer twice. The square root of x minus 4. Raise your hand. John. Down 4. Good. Number 2. The square root of x minus 4. Brett. 4 to the right. Excellent. Number 3. The square root of x plus 1. Grace. You got it. Up 1. Number 4. Level 2. The square root of x plus 2 minus 5. Zach. Left 2, down 5. Is he right? He is. Nice job, Zach. Who wants to go next? All right, Grace, you're up. Y equals the square root of x minus 10 plus 1.
No, wait, to the right.
Nice.
10.
Good.
Up 1.
Up 1. Excellent job. All right, who's going next? All right, John's going next. Noah, you make up the equation.
Square root of x minus 15 plus 10.
Plus how much? John? Good. All right, John, you're making the next one. Go.
Square root of x minus 4
Minus 20. I'm going to make it minus 200 just so they're different. All right, who's going to answer John's question? All right, Kyle?
To the right 20 and then down 200.
Nice. All right, Kyle, you make the next one. John, question? Yes. Go ahead, Kyle.
Square root of x plus 7 minus 26.
Who's got it? Noah.
Left 7 and back.
Level 2. All right. Level 3. Thoughts? Any thought? Guess. Luke? Nope. Nice idea. Did I add or subtract anything?
That'd be the same.
Abby, you had your hand up. What do you think?
Would it be like flip?
Yes, exactly. It looks like this. Here's the parent function. Something like that, right? Okay. Here's your answer, Abby. I think so. Nice job.
Would it be flipped to the other side? Or
No, it just flips top to bottom. That's it.
Not side to side.
Yeah. Yeah, Brett? It would only flip like that if the negative was on the inside. But we're not going to do that. But it would, and it could. So that is a possibility. Let's just do a little investigation to show you. See if I can put this on the screen. Clear out y. Let me delete that. So if you take the square root and I put a negative on the inside, just like you expected. So it's still that parabola shape though, isn't it? But it flipped there. Whereas Abby's flipped there. So you could have it any direction, but notice, is the shape still the same? Yeah, it's still the shape of the parent graph. The question is up, down, right, left, flip. Now I don't think you have any flips on your homework, but I just thought I'd show it to you because it's kind of a fun advanced idea. So,
Then we have our test.
no. But how about this? Are you guys okay here?
Okay.
Ryan, you cool? You comfortable? James, I feel okay? The only thing that's hard sometimes is people need to remember this is the opposite of what it says, but the other one is exactly what it says. Katie? Yes. All right, hold on. So we got done here. Very short, very simple. I gave you graph paper, so we should be able to knock this out, I would think, in less than 10 minutes.